Hello everyone. So in this video, I'm going to discuss some problems from a particular chapter called net present worth. Okay, so this is a chapter from economic engineering book. So in chapter 5, net present worth, there are six different topics. So these topics we are going to examine one by one, and then we will see. First is identifying cash flows, then payback period in the two methods, then net present worth, future worth, capitalized equivalent, and mutually exclusive alternatives. So we'll try to cover these topics. So first one is identifying cash flows. So for that, we will begin by this quick problem that is, taken from that engineering economics textbook. So right now, the problem is 5.2. So let us try to understand this problem. So if you look at here, the question is identify cash inflows and identify cash outflows. Okay, so basically we need to identify the cash inflows and outflows. So we need the first is the period. Okay, so the n. So it will be 0, 1, 2, 3, 4, 5 because in the question it is mentioned, that the period of the project is 5 years. Okay. So I'll just pause. You can pause the screen, read the question for yourself. But the main part of the question starts from this point. Okay. So it is expected that the new automated system will save $45,000 per year in labor. Okay. So, what is the savings? Okay, so I'll write here savings is $45,000. Okay, so uh, I'll write it $45,000 per year. So this will become positive cash flow, or we can say cash inflows. Okay, so here I will write inflow. That means the cash that is flowing into the company. So in the zeroth year there is no cash inflow, but then afterwards the cash inflow is 45,000, 45,000, and so on. So you just mention that here like this. Now in the end of last year, so here you can see one point here. So we have taken this data. Then here you see the expected net salvage value of the system estimated to be $3,000. So salvage value will be added as an inflow in the last year. So instead of 45, I will say 45 plus 3. So it is $48,000, okay, including the salvage value. Okay, so the salvage value S6, $3,000, and the life of the thing project is 5 years. Okay, so inflows we have written. So this also we considered. So the new system will cost about 30,000. So here I want to make a small change. Instead of 30,000, I want to consider 60,000. Okay, so this is I'm changing the question so that it will be more interesting. Okay, 60,000 to build and test the prior to operation. So 60,000 will be the cost of the system. So that will be shown as the outflow. Okay, so outflow in dollars is 60,000. Okay, so let me make a table like this. So now, what is this is the initial investment, right? 60,000. So this is what I'm meant here. It is expected that operating cost, including income taxes, will be 5,000 per year. So this is the operating cost. So operating cost also is the outflow. So I will mention that here, 5,000 every year for 5 years, like this. The system will have 5 year useful life. We already considered this, and like this. So now the cash inflows. So inflows we have done. Part A is completed. So this is the cash inflows, and cash outflows over the life of the project. So that is the B part. So this is what we have written. We covered everything, and determine the net cash flows over the life of the project. So that is part C. What is the net cash flow? Okay, so here you can see net cash flow in dollars. So here, what you have to do, you have to take outflow minus inflow. I'm sorry, inflow minus outflow. Outflow will be negative, inflow will be positive. So here, so it will be minus 60,000, and here it will be 45 minus 5. So it will be 40. Okay, so plus 40,000, plus 40,000, plus 40,000, and so on. Here, 48 minus 5, it will be 43,000, like this. So this is net cash flow. So this is what completes the ABC part. Now let's continue with this problem. Refer to the problem 5.1, answer the following. How long does it take to recover the investment? So when it says how long does it take to recover the investment, it is nothing but simple payback or conventional payback. So for that we need to calculate the project balance. Okay, so uh, that means here you take the cumulative sum of cash flows, okay, or you can say cumulative cash flows. Okay, so what is the cumulative cash flow? So 60,000 will be minus 60,000. Then 40,000 is the is what we have to add to this one. So minus 60 plus 40, it will be 20,000. Then 20 plus 40, it will be 60,000. And just a minute. Yeah, 60 plus 40 will be 100,000. I'm sorry, minus 60 plus 40 is minus 20. I'm sorry. So then this will become minus 20 plus 40 will be 20. And then 20 plus 40 will be 60. 60 plus 40 will be 100. And 100 plus 43 will be $143,000. So this is the cumulative uh, project balance. So now what we need to do is recovering the investment, right? So payback period. So we need to make a small chart. I'll show the chart here. So we can consider this as 0, 1, 2, 3, 4, and 5. And you need to make the step chart for this one. So we are having minus 60 to 143, right? So let's call this as minus 60 minus 20, 20. So here it will be 0, and it will be 60. Let's make it 100, and let's make it 140, something like this. Okay. So now in the year 0, we are here. Okay. So 0 to 1, it will be like this, minus 60. So next, at 1, it jumps to minus 20. So here, minus 20. And at 2, it jumps to 20,000. Okay. So at 2 plus 20, it will become. Let me take a sketch pen. So this will be plus 20. Okay. And it will go 60, 100, 143. So next it will go to 60, then it will go to 100, then it will go to 143. So 60, 100, 143. So this chart is in thousands of dollars. Okay, so now I got here. So now most important is wherever 0 is there, I make a horizontal line there. So it can be noticed that between the 1 and 2 years, the value changes from negative to positive. Okay. So here it touches 0 here, but this is not this is at the end of the second year. But this particular jump may happen gradually. So what we can do, we can just draw a straight line like this. So now here it is intersecting somewhere here. So that is your conventional payback. Okay, so payback period. Now, how do we calculate this payback period? So look at this height difference. Okay, so this height difference is how much? It is 40. Okay, so 40,000 is the height difference, right? $40,000, and that is achieved. So here it is minus 20 to 0. It will take exactly half. So you can simply take the ratio. So that is 20 by 40. that is zero point 0.5, or that is zero point 0.5 years. Okay, so that is already 1 year is over here. So payback period is 1.5 years. So this is the answer to this particular question. How long does it take to recover the investment cost? Here the answer is 1.5 years. Okay. Now let's look at the another part here. If the firm's interest rate is 15% after taxes, what would be the discounted payback period for this project? Now the key word here is this one, discounted. Okay, so if I go back to the topics, see, there are identifying cash flows is the first topic. Under payback period, conventional and discounted. So this discounted is little different procedure. So what we have to do is that we need to calculate the cost of funds. Okay. So let me show you how it is done. Okay, so how do we calculate this cost of funds? Okay. So what you do here, I'll just add one more column here. See, 15% is the interest rate. Okay, so that is mentioned in the question here. If the firm's interest rate is 15%, so what is the cost of funds? Now I have to make a discounted balance. Okay, so here discounted project balance. So this is important. So discounted project balance in the first year it will be same. So now don't look at this particular column. Okay. So this project balance is without discounting. So now I'll take this net first year will be same 60,000. Now what is the cost of this 60,000? So I have to take 15% and then uh, mention the 15% of 60,000. Okay, so what is that? So let me calculate. I'm just getting my calculator. Okay, so here I have to do 0.15 into 60. So I'm getting 9,000. Okay, so the 9,000 will be the cost of the funds that will be negative. Why negative? Because this is the amount we have already paid. Okay, the outflow is there 60,000. So this 9,000 will add to the net cash flow. See, what is the net cash flow? Plus 40,000. But then this 9,000 has to be subtracted. So the net cash flow will reduce, and here the project balance. How much will be the project balance? Okay. So let me show. So six minus 60. Okay. So 60,000 with a minus sign. So this is the old balance. To that balance, positive cash flow 40,000 will add. So I'll take plus 40. But from this cost of funds, 9,000 will be subtracted. So minus 9. So I'm getting minus 29,000. So this minus 29,000 will be the discounted project balance. Now, what is the 15% of that? So you multiply by 15 into 0.15. So I'm getting 4350. Okay, so minus 4350. So that is the uh, discounted like cost of fund. Now this one again I need to calculate the fresh balance. So what is the net cash flow? 40,000 is the net cash flow. So I'll go minus 29. So 29,000 with a minus sign. To this I will add 40,000, and from this I will remove 4350. So I'm getting 6650. So this is positive. Okay, so this is positive. So now the cost of funds will also become positive. So let us see that. So into 15%. So here it will be 990. I'll round it to 998. Then based on that, what is my new project balance? 6650 plus 40,000 plus 998. So I'm getting 47,648. Again 15% cost, so into 0.15, so I'm getting 7147. To that I will add 47648. To that I will add 40,000. So I'm getting 94,795. So again, to that I'll multiply 15%. Then that comes plus 14,219. To that I will add 94795. Sorry. So 94795 plus 14,219 plus 43 43,000. So I'm getting 1,52,014. So like this. So now if you again look at this, so here uh, the project balance is negative here at the end of the first year, and it become positive at the end of the second year. Okay. So now what is the difference between these two, and how long it will take to become positive? So that calculation I'll show you how to do. So from minus 29,000 it is changing to 6650. Okay, so let me do here. So at the beginning of the first year, it is minus 29,000, and at the end of the second year, it is plus 6650. Okay. So somewhere it will touch the zero. Okay. So where it is touching the zero, you need to find out. So this minus 29 has to be cancelled. So it will be 29 plus 6650. It's a simple fraction calculation. So let us do how much is this. So 29,000 plus 6650. So this one I will take the inverse and multiply with 29,000. So this comes 0.813. Okay, so 0.813 years. Okay, so this is the fraction of the year. So if I multiply with 12, I will get how many months? Okay, so into 12, so it's about 9.76 months, or 9.76 months. So therefore, what is the payback period? So discounted payback period is 1 year, 9.76 months. Or mathematically, you can say it is 1.813 years. So this is the difference. So earlier, if I go back, see the regular uh, recovery, like payback period, is 1.5 years, whereas here it is 1.8. What was that? 1.813 years. So this is about the first part, that is identifying the cash flows and calculating the payback period, both conventional and discount. Okay. Next, we will do some more problems on these other topics. See you in the next video. Thank you.